Hi everyone, this is Miss Weaver, and this is the video for section 1.6, part 1. The key ideas in section 1.6 are basically all about experimental design. So in this first video, we're going to talk about some definitions, and in the second video, we'll look at the different types of experimental design. So our ESO lens for section 1.6 is probably, a lot of it is going to be in this supported level. Can you, if you need to design an experiment, can you know it exists, can you have notes to set up that design? So the actual designs, I think, are something that would fall under that supported level. And also, honestly, a lot of the definitions. As far as independent, I would think that it would be like knowing the difference between explanatory versus response. Not that you can't look that up, but I just feel like that's one of those things, and that could even end up kind of falling into either of these, because just understanding the context of that. What does an explanatory variable mean? Well, the explanatory variable, that's the variable that I'm potentially changing, and the response variable I'm comparing based on, how did I change? The explanatory variable, and then what changes did that affect in the response? So the easiest is height and weight. If I have height and weight, technically I could flip those around, and I could, if I were drawing it on just a regular graph or something, and plotting each person as a dot. So we call that a scatter plot. We'll talk more about graphs in chapter 2, but I'm sure everyone's seen a scatter plot before, or most of you should have. And so, if I would put a person's height along the horizontal and the weight along the vertical, right? So if someone's a certain height, then they might probably have, weights around here. As they get taller, we expect them to weigh more, right? Now, it's very possible that a very tall person weighs a lot less, or a very short person weighs a lot more. But these points, let me make them red, are less likely to occur, even if this is kind of spread out more than I've made it. It's probably more of a cloud than a line. But still, for the most part, we expect taller people to weigh more. Because if you're taller, then even if everyone wore the same size, waist size pants, the taller a person is, the more they're going to weigh. And I want to say that the rough estimate is somewhere around 5 or 6 pounds for every inch taller. So the starting point is up for debate, and of course depends on your bone density and your bone structure, your body structure, of where your starting point is. But usually at 5 foot tall, they have a starting point. I'm not even going to mention a weight, because I haven't found one that is consistently agreed upon. But then if you're 5'1", you would add 5 pounds. If you're 5'2", you would add a total of 10 pounds, 5 more from the 5'1". And so we'd expect that to happen as someone gets taller. So the explanatory variable is a person's height. Their height explains at least some portion of their weight. So of course, what you eat and muscle mass and all sorts of other things also affect your weight. So please don't think I'm saying that only height determines your weight. But it would not make sense for us to flip that around and try to say that if I know someone's weight, then I can figure out their height. Right? Hopefully that just does not make sense. It shouldn't. If I tell you that someone is 150 pounds, but you don't see a picture, you don't know anything else about them, you just know their height, their weight. There's not an easy way to somehow say, oh, well then they must be 5'6". I don't know, something. There's no explanatory and response relationship there. So the explanatory and response, if I tell you that someone is 5'6" and you know nothing else about them, then you could say, well, medical guidelines might say that if a person is in a healthy range of weight, then it's going to be somewhere between this number and that number. And if they are, they have all sorts of underweight, where you're supposed to be overweight, obese, and so on. So I would have maybe a range, at least an idea. And I could justify that based on this idea that height does have an effect on weight. If I want, weight does not have an effect on height, right? My weight, I'm not going to lose weight and get shorter. I'm not going to gain weight and get taller. But as I get taller, which of course now I'm not getting taller anymore, but as kids get taller into their teens and sometimes even early 20s, as you get taller, you can usually end up getting adding on weight as well, even if your pant size or your shirt size doesn't change. This section, much like the rest of the chapter, really does have quite a few definitions in it. And those are important to know so that when you hear or see them in a problem or even outside of class, you understand what's being talked about. So make sure you can define things like an experiment, what are the factors, what is the treatment. And if you remember from section 1.2, treatment is the key word for an experiment. We're applying some sort of treatment and we're then observing the effects. Experimental unit, subject, control group, knowing what a placebo is, and then the idea of blinding. And of course there's single blind and double blind. And that's a lot, and that is kind of all this chapter, the definitions, and then the different types of experimental design. It's basically the entire section. So, with an experiment, we've talked about what experiment versus observational study already, like I said, in section 1.2. So if you haven't watched those videos and you want to go back, you can. Factors, when we talk about the factors of an experiment, it's really just another word for the different independent variables or explanatory variables. So I had this example that I usually go through when we're in class and doing the lecture part of this section, where we talk about they're wanting to figure out what the best way to cook a cake is. And so they try both gas and electric ovens. So those are two factors that need to be considered, two explanatory variables. Does a gas oven cook better than an electric oven? And then they also tried different pans. They tried an aluminum pan, a glass pan, and I think maybe a silicone pan, because those also affect how your cake would turn out. So there's three more explanatory variables or factors. So if I've got two different ovens and three different types of pans, I end up with 6 different treatments. So a treatment is a combination of the factors. So we would have 6 different treatments. I know it doesn't sound like it should be a treatment, but as far as the cake batter is concerned, that's the experimental unit, by the way. It's what we're doing the experiment on. We're using the same cake batter all the way through, and we're just changing what type of oven we cook it in and what type of pan we put it in. And so that those combinations of factors give us our different treatments. The experimental units, of course, the person, object, or some other well-defined item upon which treatment is applied. Sometimes we use this experimental unit and subject. Those are the same thing. Of course, we would like to have a control group if necessary or if it makes sense to. As far as the cakes are concerned, I don't think there's a control group for that, right? I mean, you've got to cook the cake. If your control group is be just raw cake batter, that's not going to be something we can compare the different cooked cakes to. So there may not be a control group. There may be other controls, and we can talk about that. A placebo is also not always necessary. So a placebo is something that's supposed to have no effect. So it could be like a sugar pill. Well, if you're testing different types of rabbit food, you don't want to have a rabbit food that has no effect. I mean, you still want to feed your animal that you're testing the rabbit food out on. So it may be that there's not a placebo. Maybe instead of a placebo, you use what's already on the market, the old brand or the old recipe, or whatever other previously used item would be. So it's not always a placebo is not always appropriate. And then of course with blinding, double blind is what we would hope to have, so that just to cut back on bias, right? If I, the experimenter, don't know which, whatever it is, rabbit food or whatever, if I don't know what type of rabbit food this rabbit is getting, then I can't let my personal opinion affect how I judge the outcomes, the response variable. Now, could you have blinding of any type when you're dealing with the cakes? Well, a cake is an inanimate object, so it doesn't know if it's being cooked in a gas oven or an electric oven. It doesn't know what type of pan it's in. So there's no blinding on the cake batter's part. And then there's also, well, now I guess there could be blinding if you take all the cakes out and you just have, a center cut piece of each of the 6 different cakes, and then you let someone else know, taste it or whatever, then there could be blinding there. But there's no blinding on the cakes part. There's also no blinding on the rabbit's part, right? The rabbit doesn't act better because it knows it's getting the new food, or vice versa. It doesn't act better because it was like, well, this is the food that I had before, and I don't want to change. I'm gonna make my coat shinier so that they'll know that this is the better food. So blinding is not always an issue, but when questions and opinions come into it, we want to use blinding when possible.